So, limits that fail to exist. So, if you take a look at this graph right here, when you come in from the left and you come in from the right, as we're approaching, only as we're approaching -4. As we're approaching -4, this will give you an answer of 6. So if we did the limit as x approaches -4 from the left, that gives you +6. And then if you come in from the right side, that would be the limit as x approaches -4 from the right. That will give you 3. So because those answers are different, then we would say the limit as x approaches -4 of f of x doesn't exist. So what's going on in this graph here? So because we have a jump in the graph, now the jump, you have to make sure it's at that x value, but because we have a jump in the x value of -4, that's what makes this limit not exist, okay? If we would have just had a hole, it would have been fine, or if the graph would have been continuous, it would have been fine. But because we have that jump in the graph there, it's going to make it not exist. Okay, so another example in another way that doesn't exist. So if you look at this graph here, and hopefully this graph will look familiar to you, this is just our 1/x graph, so a rational graph. But if we do the limit as x approaches 0 from the left. Okay, so 0 is here. Okay, we actually have a vertical asymptote at 0 there. So if we come in from the left side, this side is getting closer and closer and closer, not to a value, but it just keeps going on forever down, because remember, we're looking at y values, not x values. So the y values just keep getting smaller and smaller, so this would be -infinity, okay? So then if we look at the limit as x approaches 0 from the right, so if we look at it from the right, now we're looking at the y values, but as it gets closer and closer to 0, these values keep going up forever and ever and ever, so that reaches +infinity. Well, so then when we talk about the limit as x approaches 0, there are two things that has to be true. For one thing, the left and right have to be the same thing, but it also has to be a real number. So this does not exist, okay? So, whenever you have asymptotes, and there'll be vertical asymptotes. So asymptotes cause limits to fail. Alright, so this would have to be a real number here, and then your left and right numbers would have to be the same thing for it to work. So when you have a jump, like we had on the last problem, a jump in the graph, or when you have asymptotes, which essentially is like a jump in the graph, that's when you're going to have does not exist for your limit. Okay, so we're going to kind of throw some of these examples together. So this has a graph with a lot of different stuff going on. So you can see jumps, you can see holes, you can see parts. There's asymptotes, you can see parts where it's continuous. So we're going to kind of walk through this. So if we look at the first one, we're doing the limit as x approaches 4. And these are t of x, but it's okay. Okay, so it doesn't ask you for the left and right, so I'm not going to write all that stuff out. We're just going to talk about it. So take a look at 4. Find 4 here. If I come in from the left and I come in from the right, we are approaching the same value here. And we are approaching that y value of 2. So see, from the left and from the right, you approach 2. Well, something to notice is that graph is continuous at 2, or sorry, at x equals 4, so that's why it approaches that 2. Okay? So for the second one, the limit as x approaches -3 of this graph. Okay, so if we find -3, here's -3. Now -3 has a hole, but it's okay. If we come in from the left, we approach 3. If we come in from the right, we approach that y value of 3. So even though there's a hole here, it's perfectly fine, but if you come in from the left and from the right, you're both approaching that +3 as your y value. Alright, so then for number 3, the limit as x approaches 0. Okay, so x is 0 is here. Okay, if we go from the left side, we are getting bigger and bigger and bigger, so it would be infinity. And on the right side, it would also be infinity. But remember, for the limit to exist, okay, for the limit without being left or right, it has to be a real number. So because we have that asymptote there, this is going to be does not exist. just so you'll have a reason. So it's because we had that asymptote there. Alright, so if we take a look at number 4, the limit as x approaches negative 6. Okay, so here's negative 6. So this one is a little, we didn't talk about it a lot. You will talk about it next year in calculus. But for negative 6, if you come in from the left side, there's not even a graph here. Now, if you come in from the right side, you approach 3. But because there's no graph here, you can't even do that part. So this one's actually going to be doesn't exist. And that's because it's at an endpoint. So at an endpoint, you can't see where the graph is on one of the sides, so you can't technically find a limit of it. Okay, so that one was a little tricky if you want to put a little star beside it. Alright, for number 5, we're going to do the limit as x approaches 2. So if we find 2, here's 2. Oh, I already see there's a jump at 2, so that should be an alarm to us. But if we come in from the left, we approach 3. If we come in from the right, we approach 2. Well, if we approach 2 different numbers, that means our limit doesn't exist. So graphically looking at that, we had a jump in the graph, which is what made it not exist. Okay. So just looking at the graph in general, we had this asymptote, it doesn't exist, and this jump. Holes are okay. And then the last one for this one, the limit as x approaches 5 of t of x. So if we take a look at 5, here's 5. Well, it has a hole, but remember, holes are no big deal. If you come in from the left, you approach the y value of 2. Come in from the right, you approach the y value of 2, so this is going to be 2. Okay, what I mentioned at the last video that I didn't like the examples that I had. If we are not talking about limits at all, because on your homework assignment, I'm going to have some of this. If I ask you, and I'm just going to call this number 7, if I ask you f of negative 3, okay, we're not talking about limits, so it doesn't matter what the graph approaching. This just means where is the point located. So not a hole, but the actual point. So if you look at negative 3, we have a hole here, but the actual point, the y value, the actual point we'll go to would be that 8. Okay, so another example in that, let's say I ask you f of 2. So if you take a look at 2, that's where we have that jump, but one is open and one is closed. You want to get the closed point, so that y value would be at 2. So think about this as in the closed point if there's an open and a closed one. Okay? Alright, so moving on to the next your turn problem. So different graph, same kind of questions they're asking us here. So for the first one, we have the limit as x approaches negative 3 of our graph here. So if we find negative 3, I kind of like to look at it. There's a hole, so it's okay. You're going to have an answer. If you approach the left, you get the y value of 3. If you approach the right, you get the y value of 3. So this is going to be 3. Okay? If you want to like just write hole so you know that that's okay, then you can put that in. Okay, then we're going to have the limit as x approaches 0. Alright, so here's 0. Well, the graph of 0 is continuous, so it should be good. If you come from the left, you approach 3. If you come from the right, you approach 3. So the answer is going to be 3 here. So for that last one, for the limit as x approaches 0, we saw that it was continuous, but so we know if something's continuous, it will definitely have a limit. So then if you take a look at the third one, this is the limit as x approaches negative 2. Alright, well here's negative 2. Oh, it looks continuous, so we should have an answer. So if you come in from the left, you get 1. If you come in from the right, you get 1. So this is going to be 1, and we knew it was continuous, so we knew it had to have an answer. Okay, and then the last one for this one, we have the limit as x approaches negative 1. Alright, well taking a look at negative 1, ooh, I see there's a jump. So we know when there's a jump, that means that the limit can exist. So jump and asymptote. Well, let's just take a look at y. If you come in from the left, you approach 1, but if you come in from the right, you approach 2. So they have different limits from the left and right, which is what a jump does, so it doesn't exist. So if you can start seeing the things of the graph, that way you can tell where your answer is supposed to go. Okay, kind of go through this real quick. So for the next one, we don't really have a calculator, so it is perfectly fine. I'm going to just draw us a picture of the graph real quick. really all you need is graphically to be able to see this, so it's fine. So here's what the graph would look like here. And they are asking us the limit as x approaches 0. Well, if you come in from the left and you come in from the right, you get two different values. So this would be does not exist. Okay, and you know, if you wanted to think, oh, there's a jump in the graph, so I know it doesn't exist anyway. So if you were to graph it on your calculator, that's how it would look. And then for this next one, so once again, I'm just going to kind of sketch the graph for us here. There's actually a hole here. And so some of you don't have calculators, that's why I'm just kind of doing this. So we're doing the limit as x approaches 2. Well, this is 2 right here. I will tell you this gives you 1/4 here. Okay. So if you come in from the left and you come in from the right, they give you the same thing. It gives you 1/4. And it's just a hole there. So that's why we ended up with an answer. Now, if we were looking at where this asymptote is, we wouldn't get an answer. But we were looking at positive 2 there, not at negative 2 where the asymptote is. Alright, and then the last thing, let's see if I can squeeze it in. So we have another graph here. The first one asks you the limit as x approaches -3, and it does say from the left. Okay, so here's -3. If we come in from the left side of the graph, that gives you that y value in somewhere around -1. It might not be perfectly -1, but somewhere around there. And then the second one says the limit as x approaches 2, and it has the plus, so from the right side. So here's 2. If we come in from the right side, well, it's approaching that -0.5. And then the last one says the limit as x approaches -2. And it doesn't say left or right, so you have to look at both. Well, here's -2. It's continuous, so we should get an answer. So from the left and from the right, we get 0 for both of those. Okay? So if you're doing the left or the right, you can get an answer. It doesn't matter if it's a jump or if it's continuous or anything like that. But if you're doing the actual limit that's not just the left or right, make sure you look at those features of the graph. Okay? So whenever you have a jump and you have an asymptote, that's when you need to be careful that your limit from the left and right are not going to be the same thing, and it'll make your limit not exist. Okay, so that gives you a brief review, or I guess a brief insight into the limits graphically. And when you take calculus, you will learn a whole lot more with graphs. This is a very good start and will help you kind of get you on the right track for next.